All right, today we're going to take a look at another type of radical that exists called a cube root. We've mostly been working with square roots so far this unit, but we're going to extend that into something called a cube root. So to get a visual for that, of what a cube root actually is, I want you to think about this question. So we have here different types of Rubik's Cubes. I want you to think about how many of the little small cubes are needed to make each cube. Okay, so in that first Rubik's Cube, we can see that it's basically just four sides or four faces on each side. But I'm looking for how many small cubes are needed. So in other words, this cube right here in the upper corner closest to us in the picture represents one cube. So it looks like there's 4 cubes on the top and 4 cubes on the bottom. Now the way that we calculate that is we can multiply, kind of like volume, length times width times height. So a length of 2, a width of 2, and a height of 2. 2 times 2 times 2 is 8. There are 8 small cubes that make up that shape. In the next one, which is like a standard Rubik's Cube, it's basically each face is 3 by 3. We look at this front side and think about how many cubes are there that make up this front face. It looks like we have 9 total cubes that make up this front facing side. But then that extends 3 deep. So if it's 9 times 3, that's going to give us 27 cubes to make up that shape. Or another way of looking at that is 3 times 3 times 3, the dimensions of the length times the width times the height, which is 27. So there's 27 cubes that make up that standard size Rubik's Cube. Now, an advanced level Rubik's Cube shown on the right, we can see it has a length of 5, a depth of 5 or width of 5, and also a height of 5. So the total number of cubes is equal to 5 times 5 times 5, which is 125. So to extend that a little bit further, here's a bonus question. If a cube is made up of 1,331 little cubes, how long is each side? In other words, what number times itself again is going to equal 1,331. See if you can figure that out. Use a calculator. All right, what is a cube root? As we're looking at our topic title for today, the cube root of a number y, so the cube root of y, is the number such that x to the third power equals y. For example, as we just saw on the previous screen, where we said 2 times 2 times 2 equals 8, that means that the cube root of 8 is equal to 2, because the number 2 was multiplied 3 times to get the value inside the radical symbol. So the cube root of y is x if x times x times x equals y. Kind of goes along with what we know about square roots. It's just that with square roots, we have this imaginary index of 2. The square root of 16 is 4 because 4 times 4 is 16. The cube root of 64 is 4 because 4 times 4 times 4 equals 64. So when we're dealing with cube roots, we kind of have to throw out the window what we know about perfect squares and extend that to perfect cubes. So that index, that little number in the corner of that radical symbol, indicates how many times the base is multiplied. And when there's not a number there, it's that invisible 2 as an index that implies that it's a square root. Okay, so when you don't see a number there, it's actually a 2. Otherwise, if it's any other type of root, you will see a number just like we do in this cube root of 64. So our goal today is to be able to simplify cube roots. Now, sometimes, like in this example, the cube root of 1,000, we look at our list of perfect cubes, down the side. So 1, 8, 27, 64, 125, and so on. Those are all perfect cubes because they're the result of multiplying a number by itself 3 times. For example, 5 times 5 times 5 is 125. So 125 is a perfect cube. But 1,000 happens to be in our list of perfect cubes because it's the result of 10 times 10 times 10. So the cube root of 1,000 is exactly 10. Now I'm going to show this a little bit different way because it's going to help out later. I'm going to write 1,000 as 10 times 10 times 10. Remember when we simplified radicals way back? I think it was day 1 in this unit. We said if you had 2 of the same thing in a square root, you could simplify it because it represented a perfect square. Well, in cube roots, because our index is 3, I need to make sure that I have the same factor 3 times when I simplify that. So the cube root of 1,000 is just 10. Now the cube root of negative 162. You might be tempted to think, well, I can't take the cube root of a negative number because we couldn't take the square root of a negative number. However, think about it this way. What number times itself again equals negative 162? Is it possible to multiply a negative times another negative and still get a negative answer? Absolutely it is. And that's how you can take cube root of negative numbers. We don't even have to mess with I, the imaginary number here. So let's see, negative 162. So I know my answer is going to be a negative number. So when I take the cube root of this, it has to be negative. But when I look at my list, I don't see 162 as a perfect cube. But instead, I do see a number that I can divide out of 162. Let's see, I think I can divide it by 27, maybe? Let's check that. So 162 divided by 27 is 6. In other words, 27 times 6 is 162. So I'm going to rewrite this cube root as negative 27 times 6. And I put the negative with the perfect cube, right, this number over here, because if 3 cubed is 27, negative 3 cubed is negative 27. All right, negative 3 times negative 3 times negative 3 is just the opposite of 3 times 3 times 3. So I do know that this cube root of negative 27 is exactly negative 3. And then I still had that 6 left over inside the radicand. So it's negative 3 times the cube root of 6. Now when you write your answers for cube roots, please make sure that you keep that index of 3 so we don't accidentally look at it as a square root, because we obviously know square roots and cube roots are very different. One thing you could do is just double check on a calculator that you're getting the same overall values here, that your expression at the end is the same as the expression at the beginning, just to make sure that we also have, well, a reasonable answer that's correct. And then when you do get it down to a cube root like this, make sure that there aren't any other perfect cubes over here that you could also simplify out of it. So in other words, is there a number that you could divide out of 6, for example? But 6 falls in between 1 and 8. And yes, we can divide it by 1, but that's not going to simplify anything. So you want to check really to see if you can divide any of these numbers out of what's still left over in that radicand. Let's look at some more. Okay, here we have one that involves variables as well. So we have the cube root of 24m to the 3rd power. And it's going to be helpful to think of this as the cube root of 24 and then also the cube root of m to the 3rd power. So kind of keep these separate. Now 24 is not a perfect cube. It's not over here in my list. 27 is as close as I can get, but that's not the same. So it's not a perfect cube. But I do realize that I can divide 24 by 8. Okay, 8 times 3 is 24. So I'm going to simplify 24 as 8 times 3. And then I'm going to write m to the 3rd power as m times m times m. So there I'm just writing an equivalent expression for what I started with. Now let's look for perfect cubes. We said 8's a perfect cube. So since 2 times 2 times 2 equals 8, the cube root of 8 is 2. And since m times m times m is m cubed, the cube root of m times m times m is m. And what's left over that I couldn't simplify is still that 3. So I have the cube root of 3 as my radical part. So 2m times the cube root of 3 is my simplified form. All right, for my next example, we have the cube root of 16xy. Now, when we're looking at how to break this up, I can see that 16 is not a perfect cube. Again, it's not over there on my list. But what can I divide 16 by? Again, I can divide 16 by 8. 16 divided by 8 is 2. So I am going to rewrite this by breaking it up as 8 times 2 for the 16. And then I also had times x times y. So my perfect cube is the 8. I don't have 3 of anything else, and 2 is not a perfect cube. So the cube root of 8 is 2, since 2 times 2 times 2 is 8. And then it looks like I still have the 2xy left over in my radical. So 2 times the cube root of 2xy is my simplified form. All right, so here we have the cube root of 56 x to the 5th power y. Let's see, 56 is not a perfect cube. It would be right in between 27 and 64. So I want to check to see if I can divide it by 27 or divide it by 8, those next smaller numbers. So I'm going to grab my calculator again. I'm going to take 56 divided by 27. And that doesn't work. How about 56 divided by 8? That sounds like it's 7. Yes. 8 times 7 is 56. That's my factor pair that contains a perfect cube. 8 times 7 is 56. And then I had x to the 5th power, 1, 2, 3, 4, 5, and a y. So let's see, what are my perfect cubes? 8 is a perfect cube because we saw right here in our list, 2 times 2 times 2 is 8. Cube root of 8 simplifies out to be a 2. 7 is not a perfect cube, so I'm going to leave that there. And then when I get to my variables, because it's cube roots, I need to have 3 of the same factor. So I have 3 x's one time, and I don't have 3 more x's, so I can't group together another one and simplify it out. So I'm left with a 7, and x times y. So x squared y is still in the radical for the cube root. So my simplified form is 2 times x times cube root of 7x squared y. All right, for our next one, the cube root of negative 16, a to the 3rd power, b to the 8th power. All right, so we've got lots of variables in this one. But let's start with that cube root of negative 16. See if we remember how to treat that negative. First thing I want to look for is a 16 in my list of perfect cubes, and I do not see 16 because it would be in between 8 and 27. And that can be confusing because 16 is a perfect square. 4 times 4 is 16, but it's not a perfect cube. So what we want to do is try to break it down into smaller factors that includes perfect cubes. And I notice that I can divide 16 by 8. It's the result of 8 times 2. And since I really need this to be a negative 16 when I break it up, it has to equal negative 16, I want to put the negative with the perfect cube. Because if 2 times 2 times 2 equals 8, negative 2 times negative 2 times negative 2 equals negative 8. So negative 8 is also a perfect cube. All right, and I've got my A's and my B's. And, I could write them out. I'm going to run out of space, so it won't look very good. Or I can just keep in mind that if I have 3 of the same variable, I can keep that grouped together as a perfect cube. So a to the 3rd power is a perfect cube. And then for b to the 8th power, I'm going to split it up as b to the 3rd power times b to the 3rd power. So that would be like b times b times b times b times b times b. And then I would need 2 more. So I'm going to write it as b squared. So there's my b to the 8th power, just kind of broken up into 3 parts. All right, so perfect cubes. I have negative 8's a perfect cube. Since 2 times 2 times 2 is 8. The cube root of negative 8 is negative 2, which simplifies out. I have a cubed in the radical area, so the cube root of that is just a. The cube root of b to the third power is just b. The cube root of b to the third power again is b. And I'm left with 2b squared in my radical. I almost forgot the little exponent or index there. So now to write this, I gotta just multiply all that stuff at the beginning together. Negative 2 times a times b squared times the cube root of 2b squared. And that's my simplified form.